Okay, so today we're looking at linear quadratic systems. Okay, so we did this earlier in the year where we solved systems of equations by graphing, by substitution, and by elimination. You will be doing the same thing this time. Okay, so remember that, and I put stars beside this so that you know it was important. The solution to a system is where the graphs are going to intersect. So looking at this example right here, the solution to this system is where these two graphs intersect. So what point is this where they intersect? 1, 2, 3, -2. So our solution would be 3, -2. Very good. Okay. In this second one, we're looking at where both of these lines intersect, so that would be right here. So from the origin, we'd go left 1, up 2, so that would be -1, 2. Okay, what about this example here? Do they intersect? Okay, so does that mean we have a solution? So that would be no solution. Okay, so no intersection means that there's no solution. You can get that little pencil right there. All right, so now we're going to look at it with a quadratic function and then a linear function. So if the line goes through the u twice, there's two solutions. If it's sitting on the line graph, it's one solution, and if they never touch, it's no solution. Do y'all think y'all can remember that? We did something like this, yes. Okay, so in number 1, we are trying to find all solutions to this system. Our second solution is going to be, we count from the origin and we go down 2. So we didn't go right or left, so that means that it would be 0, -2.
Are we going to do graphs like that?
Probably. Okay. Looking at number 2, do these two graphs intersect? No. So what would my answer be? No solution. Okay. Then number 3, how many times do these graphs intersect? Once, right here. So to figure out what this point is from the origin, we're going to have to go right 1, down 1. So that would be 1, -1. Okay. And how many times do the two graphs intersect in number 4? Twice. Here and here. So we want to write down those 2 points. So let's do this one first. To get here, I'd go right 1, down 2. So this would be 1, -2. And to get to this point, we go right 1, 2, 3, 4, up 2. So this would be 4, comma, 2. Is everybody okay with counting along the x and y axis? Yes. Okay, we'll pay very close attention. Okay, so now we're going to review exactly what we did at the beginning of the year when we did substitution or elimination. On this one, you can answer that, Khalil. In this one, I would use this to replace y because y is already by itself. So every time when we see y, we're putting in negative x plus 1 in the other equation. So y is right there. So if I rewrite this, I'm going to get negative x plus 1 equals x squared plus x minus 2. Okay? So all I did was replace this y with exactly what it's equal to. So negative x plus 1. Now, I want to get everything on the same side. Okay? So let's move both of these things to the other side. So if I move negative x, how would I move negative x to the other side? You add x. So I'm adding x to both sides. You want to make sure you're combining your like terms. So this goes away. I'm left with 1 equals x squared plus 2x minus 2. Okay? Then I need the 1 by itself. I mean the 1 on the other side. So how do I move the 1 to the other side? You would subtract 1. So that's going to give me x squared plus 2x minus 3. And then instead of having equals 0 in the front, I'm going to put equals 0 in the back. Okay? So from here, what do you think we're going to have to do to solve for x's? Yes, trinomial method. We're going to have to factor this. Okay? So what is going to multiply to give me a negative 3, but add to give me a positive 2. Negative 1, positive 2. No, that won't work. Negative 1, positive 3. Okay. That's going to be x. I thought you said positive 2. I'm sorry. X minus 1, x plus 3. Okay. So that means this x equals 1, and this x equals negative 3. Okay, so my solution is actually a pair that is an x and a y value. I only have my x's. Now I need to find my y's that go with them. So very good. I plug in my x's. This is the shortest equation, right? This one right here. So that's the easiest one to plug it in. So if I put 1 in for x, what is y going to equal? 0. So when x is 1, y is 0. Now, if I plug in negative 3 here, I get a negative 3. What's a negative 3? A positive 3. So 3 plus 1 gives me 4, right? So when x is negative 3, y is 4. Okay? So let's try number 2 now. So in number 2, I'm going to take what y is equal to, negative x plus 5, and I'm going to put it in the place of y. So I'm going to get negative x plus 5 equals, and then I'm just writing down x squared minus 6x plus 9. So basically we just set the two x equations equal, if you want to remember it that way. Then we want to get everything on one side. So to move this negative x over here, I'm going to have to add x to both sides. I know it goes with 6x over here because they only have one x. So that's going to give me 5 equals x squared. What is technically in front of this x right here? A 1. Okay. So negative 6 plus 1 is a negative 5x plus 9. Okay. Then I want to move this 5 over. So to move the 5, I do the opposite and subtract since it's positive. And that's going to give me x squared minus 5x plus 4. And instead of putting equals 0 in the front, we're going to put it in the back. Now, we need to factor this. So if we factor, we're looking for something that multiplies to give me 4 and adds to give me a negative 5. So what do y'all think? It can't be 2 and 2 because 2 and 2 doesn't add to 5. So what's the only other multiple of 4? 1 and 4. But how do I make it a negative 5? If I make them both negative, would they add to be a negative 5? Yep. Okay. So my factors are going to be x minus 1 and x minus 4. So that means that this x is going to equal what? A positive 1. And this x is going to equal a positive 4. Now, I need an x and a y value, so we have to go back and plug them back in. So if I plug in a negative 1, I'm going to get y equals negative 1 plus 5. What does that give me? 4. So that means when x is 1, y is 4. Then I want to do the same thing with 4. So I plug in 4 here, and I get y equals negative 4 plus 5. So that would be a positive 1. So when x is 4, y is 1. So these are my two solutions. Okay. Let's look at one more example just to make sure we got this. Yes, I'm going to do number 3. I'll probably do 3 and 4. Okay, so let's look at 3. In 3, again, we're doing the same thing. We're taking what y is equal to, 2x minus 2, and we're setting it equal to the other. So go ahead and write that down. Write 2x minus 2 equals x squared minus 2x plus 2. So 2x minus 2 equals x squared minus 2x plus 2. Okay? So from here, we want to get everything on the same side. So I'm going to subtract 2x to move it to the other side. Okay? And I'm actually going to move 2 at the same time. So if it's minus 2, what do I need to do to move it to the other side? Plus 2. So I'm going to do it all in one step. Okay? So those cancel. I have x squared. Negative 2x minus 2x is negative 4x. And 2 plus 2 is 4.
Wait, so it goes by the second. Whenever you bring over, it goes by the sign, right?
Yes. So negative 2x minus 2x. Or you can do negative 2x plus a negative 2x. Okay? So we're looking for something that multiplies to give me 4, adds to give me negative 4. So what would those factors be? Negative 2, negative 2. Okay, so that means x minus 2 and x minus 2. Okay, so then this x would equal 2. Do I need to write it twice? No, because it's going to be the same point. So now I need my y value. So I'm going to take this x, plug it back in here. So I get y equals 2. And then we're going to replace x with 2 minus 2. So 2 times 2 is 4. 4 minus 2 is 2. So that means that our answer would be 2, 2. We did do this at the beginning of the year. All right. And it corresponds with this unit and what you need to learn. Okay. All right, let's look at 4 as well. We might as well. So, what's the first thing that we do, Haiti? Very good. We set the two x equations equal. Okay? Then what's our next step, Haley?
You subtract 3x.
Subtract 3x from both sides. Okay, that leaves us with 2 equals x squared minus 4x plus 2. Okay? Khalil, what would I need to do? What do I need to do now? What's your question?
Oh, wait, never mind.
Yeah, I thought if you looked at it, you'd get it. Now, what do we do next?
Wait. I thought you had to.
Jalen.
Are we supposed to, so starting with the left, like x squared x, 3x plus 2, are we supposed to subtract 3x and 2? So are we supposed to subtract both of them on the left side?
Yeah.
Okay.
Yeah, that's what I'm asking. So the next step is we subtract 2, right?
Yeah.
That's what I was
I thought
asking.
you did like all in one.
Haley didn't tell me to do it all in one. So this is what we did. It does not matter if you subtract one at a time or you subtract them both at the same time. Either way, you end up with the same thing. Okay? So the next thing we're going to do is subtract 2 to get rid of this, and we get x squared minus 4x. And then what happens here? They cancel. So this equals 0. So now we don't have 3 terms. So are we going to be factoring by trinomial anymore? You're going to do GCF. Okay? So what is the GCF for this? Okay, so from here, we are going to factor by GCF because they both have something in common. What do they both have in common? X. So we're going to pull out an x, and that's going to leave me with x minus 4. So what is my x outside of the parentheses always equal to? 0. So one of my x's equals 0, and then this x inside the parentheses equals 4. Okay? Now I need my y. So I'm going to take both of these, plug it back in up here. So if I plug 0 in, I get 3 times 0 plus 2. So what would y equal? What is 3 times 0? 0. Plus 2? 2. So one of my answers is 0, 2. Then we want to plug in 4. So I'm going to do y equals 3 times 4 plus 2. 3 times 4 is 12. 12 plus 2 is 14. So when x is 4, y is 14. So those would be my two